am leaving it to you, isn't it? Now you see another beautiful question asked from the JEE Advanced. Now you can see this is made of cations X. You can see where the cations are present, isn't it? Now they are present over here. Look at it carefully. And anion Y, right? Anion Y is actually at the corners, right? Now the packing efficiency is asked after giving the diagram, right? One gets a feeling that this is the FCC lattice, but this is not purely FCC lattice. Of course, this is face centered. X which is present along with the corners which are present, right? Corners are Y and the face center atom is X. So this is not FCC lattice, because you know that in FCC lattice the corners do not touch each other, that is A is not equal to 2R. However, here you can see A is equal to 2R minus, isn't it? Because the corners are in contact. So this is not FCC lattice. Now you have to find out the packing fraction. You know that this is present at the face center. So now let's talk about what you call the anion Y, which is occupying the lattice position, that is the corners. Anion Y is occupying what? The corners of a cube, that is 8 into 1 by 8. That is equal to how much? 1. And when it comes to the cation, am I right? You can see that cation, which is nothing but X smaller, is present in face centers. So how many faces are there? 6 into half is the contribution, that is equal to 3. Therefore, when you write the packing fraction, you can see there are 1 corners R minus whole cube plus 3 cations 4 by 3 pi R plus whole cube divided by A cube, isn't it? Now we can see that A, when you are getting the value of A, you can take this length, I meant to say the length of the face diagonal into consideration. Alright. So you can see based on that I can draw a relationship between this is your R minus and this is your R plus. So you can see that R minus plus R plus is equal to A by root 2. That means half of the length of the face diagonal. Alright, so you can see that A is equal to how much? Root 2 into R minus plus R plus whole cube. Now we have to get rid of this R plus and R minus. For that you can see this is present in the square planar void. Where is your X is present? Square planar void, right? For square planar void, the ideal radius ratio, that is R plus by R minus, is equal to how much? 0.414. Therefore, R plus equal to 0.414, R minus, which I am going to substitute here. What do I get? I am going to substitute R plus in terms of R minus, plus 3 got cancelled, 4 pi, R plus as what? 0.414, R minus whole cube upon root 2 into R minus I am substituting in terms of R plus I am substituting in terms of what? In terms of R minus, that is 0.414 R minus plus R minus whole cube. You can see that your R minus is being taken common in all and it gets cancelled and you will get a standard value for the packing fraction. The only point is that you need to identify that there is anion contact in this lattice. This is not FCC. Alright. So this is one of the interesting questions. What do you say? All the questions that are asked from this chapter are